Welcome to the presentation on multiplying fractions. Well, I think today you'll be very happy because you'll find out that this is one of the few times where multiplying something is easier than adding it, I think, or subtracting it for that matter. And if you don't believe me, let's do some problems. Okay, so let's get started. Let's start with 1/2 times 1/2. So when you multiply fractions, it's very straightforward. It's essentially just two separate multiplication problems. You multiply the numerators, so you get 1 times 1, and you multiply the denominators, 2 times 2. 1 times 1 is 1, 2 times 2 is 4. So 1/2 times 1/2 is equal to 1/4. And that makes sense. That's like saying 1/2 of 1/2 is 1/4, which makes sense. What if we had negative numbers? Well, if I had 1/2 times negative 1/2, and when you have a negative fraction, it's good to ascribe the negative number. I tend to ascribe the negative number to the numerator. It's -1/2. You realize that negative 1/2 is the same thing as -1/2. Hopefully that makes sense. So 1/2 times -1/2, that's just the same thing as 1 times -1/2 times 2, which equals -1/4, which is the same thing as -1/4. What if I had different denominators? And when you're adding and subtracting fractions, that tends to make things difficult. Well, it's not necessarily the case here. If I had 2/3 times 1/2, just multiply the numerators, 2 times 1, and you multiply the denominators, 3 times 2. So you get 2 times 1 is 2, 3 times 2 is 6. And 2/6, we know from equivalent fractions, is the same thing as 1/3. That was an interesting problem. Let's do it again, and I want to show you a little trick here. So 2/3 times 1/2. As you said, any multiplication problem, you just multiply the numerators, multiply the denominators, and you have your answer. But sometimes, there's a little trick here where you can cancel out, you can divide the numerators and the denominators by a number. Because you know that this is going to be the same thing as 2 times 1 over 3 times 2, which is the same thing. I'm just switching the order on top, is 1 times 2 over 3 times 2, right? All I did is I switched the order on top because you can multiply in either direction. And that's the same thing as 1/3 times 2/2. Well, that just is 1/3 times 1, which is equal to 1/3. And why did I do that? Well, I want to show you that these twos, all I did is switch the order, but at all times we had 1, 2 in the numerator, and I had 1, 2 in the denominator. If I wanted to, and this is kind of a trick for doing multiplication really fast, so you don't have to reduce the final fraction too much, you get 2/3 times 1/3. You just say, oh, I got 2/3 times 1/2. Sorry. You say I have a 2 in the numerator, 2 in the denominator. Let me divide them both by 2. That equals 1/3. Just a fast trick. I hope I didn't confuse you. Let's do a couple more problems, and I'll do it both with the trick and without the trick. What if I had 3/7 times 2/5? Well, multiply the numerators. 3 times 2 is 6. 7 times 5 is 35. That's it. Let's do some negative numbers. If I had -3/4 times 2/11, well, that's -6/44, which is the same thing as -3/22. And we could have done that cross-dividing trick here. Let's do it again with the cross times 2/11. We say, oh, well, 2 and 4, they're both divisible by 2, so let's divide them both by 2. So 2 becomes 1, and 4 becomes 2, and then our answer becomes -3/22, right? -3 times 1 is -3. 2 times 11 is 22. Let's do another one right here. If I had -2/5 times -2/5, well, that just is equal to -2 times -2 is +4, And 5 times 5 is 25. It's 4/25. And that's just, remember, a negative times a negative is a positive, which makes sense. let's just do a couple more problems since we have a lot of time, but I think you probably got this by now. You're probably realizing that multiplying fractions is a lot easier than adding them or subtracting them, hopefully. Well, I guess it's not a bad thing if you find adding or subtracting fractions easy as well. Let's do, I'm just making up numbers now. 2/9 times 18 over 2. Well, here we have a 2 in the numerator and a 2 in the denominator. Let's divide them both by 2, so they both become 1. And we have an 18 in the numerator and a 9 in the denominator. Well, they both are divisible by 9, so let's divide them both by 9. So 9 becomes a 1, and the 18 becomes a 2. So we have 1 times 2 over 1 times 1. Well, that just equals 2 over 1, which equals 2. That was pretty straightforward. We could have done it, I guess you could call it the hard way, if we said 2 times 2 over 9 times 18 over 2. 2 times 18 is 36. 9 times 2 is 18. And 36 divided by 18, we can see 18 goes into 36 2 times. That also equals 2. Either way is fine. If you don't feel comfortable doing this trick right now, you don't have to. All that does is it makes it easier. You won't end up with huge numbers in your product that you'll have to figure out if they can be reduced further. Let's do 2 more problems. Minus 5 over 7 times 1 over 3. Well, minus 5 times 1 is minus 5. 7 over 3 is 21. That's it. Let me do one with more of the cross, with the little trick I showed you. Let's say if I had 15, and here I think you'll see why that trick is useful. Over 21 times 14 over 5. Well, clearly if we multiply this out, we end up with pretty big numbers. I think it's 220 over 105, and then you have to reduce those. And it becomes a big mess. But we can see that 15 and 5 are both divisible by 5, so let's divide them both by 5. So 15 divided by 5 is 3. 5 divided by 5 is 1. 14 and 21, they're both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. And so we get 3 times 2 is 6 over 3 times 1 is 3, which equals 2. And that's the same thing as what I said before. If we had multiplied 15 times 14, that would have been 210, I think. Yeah, 15 times 14 is 210. And 21 times 5 would have been 105, and you would have to say, I guess in this case it's kind of obvious that 210 is 2 times 105, and you've gotten 2 as well. So hopefully I didn't confuse you too much with that last problem. But I hope you realize multiplication is pretty straightforward. You just multiply the numerators, you multiply the denominators, and then if you have to reduce, you reduce, but you're pretty much done. I think you're ready now to try the multiplication module, and I hope you have fun.